vector additions. So there are different methods are there for adding the two vectors. So if the two vectors are along the same direction, we can just simply add the two vectors as vector A and vector B. They are along the same direction. We can add them vector A plus vector B or vector A plus B. The resultant vector, vector R is equal to A plus B, the magnitude of the two vectors. And if they are along the opposite direction, if we have two vectors, vector A and vector B, they are directed along the opposite direction, then the resultant vector is given by vector R is equal to vector A plus the minus of the second vector minus vector B. So this is the second method. So here we have three different methods are there. One is graphical method, second one analytical method, and the third one is component method. So in our last class, we were discussing about the first method, that is the graphical method. And under this graphical method, the third case is much with a difference. If the two vectors are inclined at an angle theta, if the two vectors are inclined at an angle theta, then we have two different methods are there for adding such vectors. What are they? What are the two laws that we are adopted here in order to add the two vectors if we are inclined at an angle theta? Unmute and say.
Triangle law and parallelogram law.
Triangle law and the parallelogram law. And in the last class, we discussed about the triangle law. So first of all, we can state this triangle law. After that, we can go to the parallelogram law. So I request all of you to please switch on your videos. So starting with the Gaya, state the triangle law of vector addition.
If two vectors are represented in magnitude and direction by the two sides of the triangle taken in same order, then the resultant vector is represented by the third side of the triangle taken in opposite order.
Opposite order, all right. The same question to align triangle law of vector addition.
Ma'am, this law states that if two vectors are represented in magnitude and direction by two sides of a triangle taken in the same order and resulting is represented by the third side of the triangle taken in the opposite direction.
Taken in the opposite order. And then Jewel, what do you mean by this term same order? What is indicates by this term?
In same manner, how it's arranged.
Same manner means in which way we are arranging the vectors in order to add. There is a particular
Head to
order. Is
tail.
there? Head to tail or tail to head?
Tail to head.
Tail to head. It is in the triangular law of vector addition, mainly we are follows the tail to head arrangement. So if the two vectors, vector A and vector B, are arranged in a tail to head manner, that is why we are consider them, they are taken in the same order. They are representing the adjacent side of a triangle. Then the third side represent the resultant vector of these two vectors, and it is taken in the opposite order. That is, the resultant vector is arranged in the head to tail order. Okay, so today we are going to discuss the second method of vector addition if the two vectors are inclined at an angle theta. That is the second way, that is parallelogram law of vector addition. So all of you write the next heading, parallelogram law of vector addition. Parallelogram law of vector addition. Only need to write the heading, parallelogram law of vector addition. So here also we consider the two vectors. One is a vector P and other is vector Q. or vector A and vector B itself, vector A and vector B. Vector A and vector B. So suppose we are consider the two vectors, vector A and vector B, such that vector A and vector B is arranged like this. Vector A and vector B. They are at the same point. Here we have two vectors, vector A and vector B, with the magnitude and direction. We know that this tail portion indicates the magnitude of vector A, and this arrow mark indicates the direction of vector A. Similarly, here also the tail portion indicates the magnitude of vector B, and this arrow mark indicates the direction of vector B. So here we consider the two vectors, vector A and vector B, with the magnitude and the direction. And they are starting from where? They are starting from the same point. Here we cannot see the tail to head arrangement. Instead of that, here these two vectors are starting from same point. So we can consider vector A and vector B as co-initial vectors. So here vector A and vector B are co-initial vectors. So here we consider vector A and vector B with the magnitude and the direction, and they are represented, or they are starting from, or they are arranging from the same starting point. So we can take them as co-initial vectors. So here we have two vectors, vector A and vector B with the magnitude and direction. They are known as the co-initial vectors, such that it is starting from the same point. It is starting from the same point. That is why this vector A and vector B is taken as co-initial vectors. Okay, so once again I will explain the consideration of the two vectors. Here we consider the two vectors, vector A and vector B, with the magnitude and the direction. They are known as the co-initial vectors, such that it is starting from the same point. The vector A is starting from here, vector B is also starting from here. Now we are going to find the resultant vector of these two vectors by the parallelogram law of vector addition. So as the name implies, here we are using the parallelogram law. So here we want to consider a parallelogram. For that, we draw a line that is parallel to vector B and draw another line that is parallel to vector A, in order to find a resultant vector corresponding to this vector A and vector B. Here we are going to use the parallelogram law. For that, we draw a line parallel to vector B and draw another line that is parallel to vector A. Then, according to the law of parallelogram, it states that the resultant vector represents the diagonal of the parallelogram with the same starting point. So the resultant vector represents the diagonal of the parallelogram with the same starting point. That is, vector R is equal to vector A plus vector B. In the case of triangle law, if the two vectors, vector A and vector B, with the same order is represent the two adjacent side of the triangle, then the third side represent the resultant vector of that particular two vectors, vector A and vector B. But here we are consider vector A and vector B, they are co-initial vectors. They are not same order, they are same point. They are co-initial vectors. These two vectors are starting from the same point. Then we can use the parallelogram law in order to find the resultant vector corresponding to the vectors vector A and vector B. In order to apply this parallelogram law, here we are elongate or extend or draw a line parallel to vector B, draw another line that is parallel to vector A. Then parallelogram law states that the resultant vector represents the diagonal of the parallelogram that is also starting from the same point. So here the three vectors, vector A, vector B, and the resultant vector is starting from the same point. So now we can state the parallelogram law of vector addition. So the parallelogram law of vector addition states that if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram, instead of triangle, here we are replace the term with the parallelogram. Okay, because here we are used the parallelogram law in order to find out the resultant vector. So if the two vectors are representing the magnitude and direction of the two adjacent sides of a parallelogram, that is drawn from a point, instead of this a point, you can use same point. That is drawn from the same point, then their resultant is represented the magnitude and direction by the diagonal of the parallelogram that is also drawn from the same point. This is what is the parallelogram law states. So all of you please copy down the parallelogram law of vector addition. Parallelogram law of vector addition. So parallelogram law of vector addition states that if two vectors, that is our vector A and vector B, vector A and vector B represents the magnitude and direction by the two adjacent sides of a parallelogram. So it represents the magnitude and direction of the two adjacent. Adjacent side means two nearby sides of a parallelogram. And it is drawn from a same point. It is taken from the same point. That is why these two vectors, vector A and vector B, are known as co-initial vectors. It is starting from the same initial point. Then the resultant vector represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. The resultant is also starting from the same end point or same initial point. So in your question paper, sometimes you can find the figures with the same order and the same point. Both are different. Same order means tail to head arrangement. Tail to head, here is also from tail to head. Here it is not starting from the same end point. So here we want to apply the triangle law in order to solve the or find out the resultant vector. Here the third vector or the third side of this triangle is representing the resultant vector. R is equal to vector A plus vector B. But if the two vectors are starting from the same end point, here vector A, this is vector B. They are starting from the same point. So they are co-initial vectors. So in this case, we need to apply the parallelogram law in order to find out the resultant vector. So you need to draw a parallelogram And here the diagonal of the parallelogram gives the resultant vector. Vector R is equal to vector A plus vector B. Is it clear? So this is the way you can identify whether you need to apply the parallelogram law or triangle law to a vector. In case of vector addition, sometimes you may be confused which law we need to apply here. So you just think whether it is given in same order or same point. If it is given in the manner of same order, you must apply the triangle law. If it is in the form of same point, you just apply the law of parallelogram law in order to find the resultant vector. So that's all the difference between the triangle law and the parallelogram law. So once again, we can recall this parallelogram law of vector addition. After that, I will give you a question regarding with that of the dimension, because I think derive an expression for derive an expression for the period of oscillation of a mass. Derive an expression for the period of oscillation of a mass attached to a spring. Derive an expression for the period of oscillation of a mass attached to a spring executing simple harmonic motion. Instead of writing simple harmonic motion, you can write SHM. Derive an expression for the period of oscillation of a mass attached to a spring executing simple harmonic motion. Executing simple harmonic motion. Given that period of oscillation depends on mass, depends on mass M and force constant K. Mass M and force constant K. Such that K is equal to, it is also given in the question paper, mt raised to minus 2. The dimension of the force constant is provided in the question paper. Force constant K is equal to mt raised to minus 2. So here you need to derive an expression for period of oscillation of a mass that is attached to a spring that executing a simple harmonic motion, such that the period of oscillation depends on two factors. One is mass and the other is the force constant K. Such that the dimension of the force constant is already provided here. K is equal to mt raised to minus 2. So how we can solve this problem? Which letter that we are used to represent the period of oscillation? Period of oscillation means?
Time.
The idea? Time. Period of oscillation means time. So what is the first step in order to derive the expression using the dimension? First step, time t is equal to, it depends on two factors. What are the two factors?
Force and mass.
It depends on force constant and mass and force constant. So T is equal to mk. We don't know how it depends. Is it is directly proportional or inversely proportional? We don't know the dependence of mass and force constant on period of oscillation. So we take the T is equal to mk. Or T is not equal, T is proportional to. Or T equal to mk, because here the force constant is already provided. So T is equal to mk. Then what is the next step? The second step. Any idea?
Powers.
Yes, we need to equate the powers. That is, T is equal to, we don't know how it is, what about the exponents of these variables, mass and that of the force constant. So we put T is equal to m raised to A and K raised to B. So the second step is also over. Then, what about our third step?
Dimensional formula.
Very good. Write the dimensional formula. What is the dimensional formula for the time period of oscillation? Dimensional formula for time. Dimension is represented by T or LT raised to minus 1. And there is a difference between dimension, dimensional equation and a dimensional formula. So here we need to express the time period in terms of dimensional formula. What do you mean by dimensional formula? Representation of a physical quantity in terms of mass, length and time. So here in LHS we have only the time period. Does the mass quantity is present here? No. So we can take m raised to 0. What about length? Length is also not present here. So L raised to 0. But the time is present, T raised to 1. That is equal to, what about in the case of RHS? Dimension of mass is m raised to A. What about the dimension of force constant K? Dimension of force constant K?
Empty raised to.
Yes, it is mt raised to minus 2. It is provided in the question paper. Mt raised to minus 2, all raised to B. Okay, so m raised to 0, L raised to 0, T raised to 1. That is equal to m raised to A, mt raised to minus 2, the whole raised to B. Now what is our next step? M raised to 0, L raised to 0, T raised to 1. That is equal to, we can split this term. That is m raised to A, and here we have mt raised to minus 2, the whole raised to B. So it becomes m raised to B and T raised to minus 2B. M raised to 0, L raised to 0, T raised to 1. That is equal to m raised to A, m raised to B and T raised to minus 2B. So here we have two m terms, m raised to A and m raised to B. So it becomes m raised to 0, L raised to 0, T raised to 1. That is equal to m raised to A into m raised to B. What is the solution? M raised to A into m raised to B.
M raised to A plus B.
M raised to A plus B. So it becomes m raised to A plus B into T raised to . Okay. Now what about the next step, the fourth step?
Equating the power on both sides.
Yes, equating the power or exponents from both sides. So here we are going to equating the exponents of m from LHS and that of the exponents of m from RHS. So by equating the exponents of m, we get a plus b equal to, what is the corresponding exponents of m from LHS?
0.
A plus b equal to 0. So this is our equation number 1. A plus b is equal to 0. Now, equating the exponents of L. In RHS, there is no term with L, so we don't need to equate the term of L. The next one is T. Equating the exponents of T from both sides. It becomes exponents of T on RHS is
minus 2b.
minus 2b. On LHS, it is equal to
1.
1. Then from this equation, we get an expression for b. Minus 2b is equal to 1, which implies b is equal to
Minus 1 by 2.
minus 1 by 2. Minus 2b is equal to 1, which implies b is equal to 1 by minus 2. 1 by minus 2, that is equal to minus 1 by 2. Okay. Now, this is our equation number 2. So, here we get the value of b. The value of b or the exponent b is equal to minus half. Then we can substitute the value of b in our equation number 1. Thereby, we get the value of a. So, the next step, what is our next step? Substitute equation 2 in equation 1. Equation 2 in equation 1. Then we are going to substitute equation 2 in equation 1. According to equation 1, we have a plus b is equal to 0. A plus b is equal to 0. But by equation 2, we know that b is equal to minus half. So substitute the value here. A minus half is equal to 0, which implies a is equal to
minus 1 by 2.
a minus half is equal to 0, which implies a is equal to minus 1 by 2.
1 by 2.
Positive 1 by 2.
Positive 1 by 2. A is equal to positive half. Then this minus 1 by 2 taken to RHS, it becomes positive 1 by 2. So here we get a is equal to 1 by 2. So we get the two values, a equal to 1 by 2 and b is equal to minus 1 by 2. Now what is the last step? What about our last step? Substitute the values of a and b into our second step. What is our second step? Second step is this. T is equal to, this is our first step and this is our second step. According to your second step, T is equal to m raised to a, k raised to b. So T is equal to m raised to a, k raised to b. Substitute the value of a and b into this equation. It becomes T is equal to m raised to 1 by 2. What is the value of b? K raised to minus 1 by 2. Or we can write T is equal to m raised to 1 by 2. K raised to minus 1 by 2. How we can represent k raised to minus 1 by 2?
K raised to minus 1.
No, we can take this term k to denominator. Then it becomes positive 1 by 2. T is equal to m raised to 1 by 2 divided by k raised to 1 by 2. or we can write that is equal to root of m by k. M raised to 1 by 2 or k raised to 1 by 2 means root of m by k. So the final equation becomes t is equal to square root of m by k. This is the expression for time period of oscillation of a mass that executing the simple harmonic motion. So this is the way we can derive the expression from dimension. So you just follow this step by step. First we are starting from the dependence of that quantities. They are provided clue that the time period of the oscillation is depends upon the mass and the force constant. We don't know how it is depends whether it is directly proportional or indirectly proportional. So you just equate them equal to mk. Then in the second step, we give the exponents to each term. That is t is equal to m raised to k and k raised to b. Then in the third step, we equate the exponents and we arrange them in terms of dimensional equation. Dimensional equations of both LHS and that of the RHS. And in the fourth step, we form an equation by equating the exponents from LHS and RHS. In the fourth step, we are forming an equation. Then we get the value of this exponents or the constant or the variables a and b. And in the final step, substitute that values into our second step. So we get an expression like this. So in the present case, it is t is equal to root of m by k. Is it okay? Okay. Now I will give you another examples. Is there any doubt regarding with these 3 chapters?